In this lecture, I'm going to discuss geometry brushes. In the world of 3D modeling, a brush is simply a 3D area of space. So this is nearly identical to our understanding of what a mesh is, but there are several key differences between brushes and meshes. First off, brushes are used for more basic shapes. So in the Place Actors panel, in the Geometry category, you can see the brushes we have available. Some basic geometric shapes and some brushes in the shape of stairs. Now, in the Shapes category, we also have some static meshes available in the form of basic geometric shapes, but as we saw in the previous lecture, meshes can be much more complex than this. In our starter content, we saw some meshes that had been created in a 3D modeling program to take the shape of a chair, and another in the shape of a table. Okay, so that's the first key difference between brushes and meshes. Meshes can be much more complex and detailed than brushes. The second key difference is in how the Unreal Engine handles brushes and meshes in memory. For example, let's say I have this brush actor here, and I make several copies of it. Each copy I make gets stored in memory, and thus each copy I make of it increases the memory demands of my game. However, if I have this mesh here, and I make copies of it, no matter how many copies I make, I'm not increasing the memory needed at all. That's because a single mesh only gets stored in memory once, no matter how many instances there are of it in your level. So that's the second difference. Meshes are better performance-wise than brushes. Okay, so now you may be wondering, if meshes look better and they perform better, what use do brushes have? The answer is that brushes are better suited for making a prototype, or a rough draft of your level. While the final version of most games will have very little or no brushes in it at all, chances are each of its levels started out made almost exclusively as brushes. So you can use brushes to sculpt the basic layout of your level and then replace those brushes with meshes once the layout is finalized. This is useful because it's easier to make changes on the simpler brushes than it is the more complex meshes. So in theory, once you have the basic layout sculpted in brushes, you won't need to keep making minor changes over and over to the more difficult to edit meshes. Okay, so that is what brushes are used for. Now let me show you how to use them. And specifically, I'll be showing you the different properties available for you to edit under the Brush Settings category of the Details panel. Alright, so some of these properties are different depending on the base shape of the actor, but one property that is common to all the brushes is the brush type. The brush type for any brush can either be additive or subtractive. So the additive type is pretty straightforward. An additive brush will add geometry to the level. A subtractive brush, on the other hand, will subtract from existing geometry in the level. So if I have this additive box brush here, and I drag in, say, a cylinder brush, and make it subtractive, and then I overlap the two actors, wherever the subtractive cylinder brush is overlapping is causing the geometry that was there to be removed. You can think of subtractive brushes as holes in the shape of the brush. Now, this feature is one of the main reasons why brushes are so well suited to sculpting overall level design. By adding and subtracting geometry in this way, you can sculpt the layout of a level much faster than you could trying to use meshes. Okay, the next property under brush settings is brush shape. So this just means, is it a box, is it a cone, is it a cylinder, and so on. So I can choose which brush shape I want to use when I'm dragging the actor into the level, but if I want to change to the shape of an existing brush actor in the level, I can do so here. Alright, so some of the properties in the brush settings are dependent on the shape of the brush being used. For example, a box brush will have X, Y, and Z properties, denoting the length of the box in those dimensions. So adjusting these values will adjust the size of the box. This is similar to using the scale property in the transform category, with one key difference when it comes to materials that I will talk about in the lecture on materials. So the box brush has these X, Y, and Z properties, but the cylinder and cone brushes have their size determined by just a Z length and an outer radius property. So the Z is how tall the cone or cylinder is, and the outer radius is how wide around it is. And for the cone, this is the radius as measured at the base. And for the sphere brush, radius is the only property used to determine its size. Okay, so the cone and cylinder brushes have a property called sides. So you might have noticed already with these brush shapes that their curved angles, so to speak, or their curved edges, so to speak, aren't actually curves, but made up of a series of flat sides. So the sides property determines how many of these flat sides the brush has. The more sides it has, the smoother around it will appear. The sphere brush has a property similar to this, which is the tessellation factor. The higher this number is, the more sides the sphere will have, and the smoother it will appear. The cone and cylinder brushes also have this property aligned to side. And all this means is, if this is checked, it will align the sides of the brush with the grid. So you can see that with that checked, this side of my cone here is perfectly parallel to the grid lines. But if this is unchecked, it won't necessarily align with the grid. Okay, so another property of brushes that is common to the box, cone, and cylinder brush is whether or not the brush is hollow. So this is just what it sounds like. If this property is checked, instead of the brush being solid all the way through, it will be hollow inside, and the brush will essentially be a shell with walls of some thickness. For box brushes, this is set with the wall thickness property. For cylinder brushes, this is set by the inner radius property. So the inner radius is the radius of the hollow part. For cone brushes, this is set by both the inner radius property and the cap Z property. The cap Z property determines how tall the hollow area is within the cone. But for each of these, you'll notice the property is grayed out unless the hollow property is checked. And this makes sense because there will only be a wall thickness or inner radius, etc. if the object is hollow. So one thing the hollow feature is particularly useful for is for quickly creating rooms or buildings. So I'm going to take this box brush here and I'm going to scale it up a bit. And then I'm going to make it as hollow as a corrupt politician's promise. Now I'll reduce the wall thickness a bit. And now I can use another box brush, make it into the shape of a doorway, make it subtractive, and now I can use it to create a doorway into my hollow cube. So now I have this hollow building here, and it was a lot faster to build than if I had to try to make it out of separate pieces. Okay, so now I'm going to move on to the stair shape brushes, which I wanted to discuss on their own since they have their own unique properties. So starting with the linear stair, which is the simplest of the three, you have step length, height, and width properties. So the length will affect the size of each step in this direction. The height will affect it in this direction. And the width will affect it in this direction. Alright, and then you can choose the number of steps for the staircase. The default is 10, but you can make this larger or smaller if you wish. The add to first step property is essentially a step height property for the first step only. So while the step height property increases or decreases the height of all the steps, the add to first step property will only affect the height of the first step. Alright, moving on to the curved stair. The curved stair has some of the same properties as the linear stair, such as step height, step width, number of steps, and add to first step, but it also has some other properties as well that pertains to its curve. The first of these properties is the inner radius. So you can imagine the curved stair as wrapping around an invisible column. And when the curved stair is selected, you will see the transform tool at the center of this invisible column. So the inner radius property sets the length between the center of this invisible column and the edge of the staircase. So you can see what happens to the staircase when I increase or decrease this property. Next, we have the angle of curve property. This will set the angle that is made between the two vectors pointing from the center of the imaginary column to each end of the staircase. So the default is 90 degrees, and you can easily see this because our x and y axis vectors here, which are at a 90 degree angle, are each pointing directly at one end of the staircase. But let's say I now increase the angle of curve. You will see that the new angle created, which would be between this vector here and a vector going in this direction, is now an obtuse angle, or greater than 90 degrees. Or if I decrease the angle of curve below 90 degrees, you can see that an acute angle is formed. Okay, and lastly is the counterclockwise property. This one is pretty straightforward. With this unchecked, our staircase will curve in a clockwise direction, and with it checked, the staircase will instead curve in a counterclockwise direction. Okay, so the final staircase is the spiral stair. And the first property I want to discuss on the spiral stair is the step height property. The step height property is a little different on the spiral stair than it is on the other two stairs. With the spiral stair, the step height won't affect how tall each step is. It will affect how much each step overlaps the step above and below it. So you can see at the default value, each step overlaps its adjacent steps by about 50%. But if I increase this value, the amount of overlap will begin to decrease, and eventually the steps will no longer overlap and begin to have some distance from each other. So if you want to make each step actually be taller, you would increase the step thickness property to achieve that. Alright, so the spiral staircase has a num steps property like the other two, but it also has a num steps per 360 property. So this defines the number of steps in one full spiral of the staircase. So right now we have 16 steps per spiral, and we say that our staircase should have 16 steps total, so therefore this staircase will currently have just one full spiral. But if I double the amount of total steps to 32, with the num steps per 360 still set at 16, I will now have two full spirals of the staircase. And if I now increase the num steps per 360 to 32, I will again have just one full spiral, but now with 32 steps instead of 16. Alright, so the next property is the sloped ceiling property. With this unchecked, the underside of the staircase will just resemble upside down stairs. But if I check this, it will make the underside completely smooth. And then with the sloped floor property, I can change the top surface of the staircase to be perfectly smooth. So I have now, in essence, changed this from a staircase into a curved ramp. Okay, so that will do it for this lecture on geometry brushes.